Hi everyone, thanks for joining me in a quick discussion surrounding the stimulus rate and interstimulus interval. These are two parameters that we sometimes see used interchangeably in our evoked potential software, but they have two very different meanings and will imply two very different values. So it's important that we understand the difference between the two, as well as the relationship between these two values. The purpose of this video is to help you define stimulus rate and interstimulus interval, as well as understand the difference between the two in the context of our evoked potential parameters. And you should also be able to calculate the interstimulus interval given the stimulus rate and calculate the stimulus rate given the interstimulus interval. I'll give you 4 practice questions at the end of this video so that you can demonstrate what you've learned. First, we'll review what the stimulus rate is and define the interstimulus interval, or ISI. We will then look at how to calculate each of those values given the other. We will practice, and then you'll try some out on your own. So let's get started. The stimulus rate is exactly what it sounds like. This is the number of stimuli delivered in a given period of time. You could also call this a frequency of stimulus. And of course, we assign the unit of hertz when we refer to a frequency or rate of anything. Recall that the unit of hertz represents cycles per second. So 1 hertz is equal to 1 cycle per second. If we were talking about our stimulus rate, a 1 hertz rate would mean that we deliver 1 pulse every second. In terms of motor evoked potentials, we use some rate of 5 to 7 consecutive stimuli when we stimulate the brain. And with sensory potentials, we set a rate of repetitive stimulus pulses to deliver to the patient's limbs. Looking at this image, if we consider the x-axis to be equivalent to 1 second, for example, we can count the number of cycles represented here, 1, 2, 3, 4, and we can call this 4 cycles per second, or 4 hertz. So if each of these cycles represented a stimulus pulse delivered to the patient, we would be delivering 4 pulses each second. On the other hand, the interstimulus interval is the amount of time between each stimulus pulse. So this is a specific unit of time, and it's usually measured in milliseconds in our field. So looking again at the image, if each of these cycles represents a stimulus pulse, we would represent the interstimulus interval as the distance between 2 cycles, which is sometimes referred to as the wavelength. Since, remember, our x-axis here represents 1 second, it makes sense that our interstimulus interval will be much shorter than 1 second. In fact, the interstimulus interval is equal to the reciprocal, or the inverse, of the stimulus rate itself. And we know that in some evoked potential systems, sometimes our software requires that we enter an ISI instead of a rate, so we have to be able to arrive at a value for it. So let's take a closer look at that calculation. We said our rate of stimulus was 4 hertz, which is 4 cycles per second. And we know that the interstimulus interval, or the time between pulses, is the inverse of that number. So let's flip the number upside down to take the inverse, and now we're left with 1 second per 4 cycles. Not exactly the unit that we need. 1/4, or 0.25, is actually the interstimulus interval, but the unit here is seconds per cycle, so we need to convert it to milliseconds. Simply multiply by the number of milliseconds in 1 second, so 1,000 milliseconds in 1 second, and then cancel out the common units. And you're left with an answer of 250 milliseconds. So the interstimulus interval that corresponds to a rate of 4 hertz is 250 milliseconds, which can also be stated as 250 milliseconds per cycle. And what if we know the interstimulus interval that we want to use, but our software requires us to enter the rate of stimulus? Again, these values are the inverse of one another. So let's take the example of an ISI of 2 milliseconds. First, we take the inverse, which gives us 1/2 milliseconds, and you could state this as 1 cycle per 2 milliseconds. But remember, we need our unit to be in hertz, which is cycles per second. So let's convert. There are 1,000 milliseconds in 1 second, so we multiply by 1,000. We then cancel our common units and come out with 500 cycles per 1 second, which is equal to 500 hertz. So our stimulus rate for an ISI of 2 milliseconds is equal to 500 hertz. All right, it's your turn to practice. Pause the video now and calculate the interstimulus interval of a 400 hertz stimulus rate. When you're ready to review the answer, press play. Okay, let's review our answers. So we have a 400 hertz rate, that's 400 cycles per second. So we need to first take the inverse of that rate, which is 1 second per 400 cycles. And now we know, excuse me, we need our interstimulus interval in milliseconds. So let's multiply by 1,000 milliseconds, since there are 1,000 milliseconds in 1 second. When we go to solve, we will cross out the common units, and our answer comes out to 2.5 milliseconds per cycle, or more commonly just stated as a 2.5 millisecond interstimulus interval. Awesome job. So in summary, stimulus rate and interstimulus interval are inversely related. You can see in the image on the left, there are fewer cycles per second, indicating a slow rate, so the time between cycles appears longer. Whereas the image on the right depicts a fast frequency rate. The number of cycles per second is higher, so the interstimulus interval appears much shorter. Rate is measured in hertz, which is cycles per second, whereas the ISI is measured in milliseconds. To calculate one value given the other, take the inverse, and then don't forget to convert those units. All right, now it's your turn to try out some practice questions on your own. So end this video and work your way through these 4 examples. We will check our answers the next time I meet with you for the instrumentation webinar. Remember, in order to meet the final objective of this lesson, you'll need to be able to complete all 4 of these problems with 100% accuracy. Thanks for joining me, everyone. Happy studying. As always, if there are questions, please feel free to reach out. Let me know how the studying is coming along. See you next time.